Hello all. So we have here is the T5 non-calculator booklet. I've just made this up. It's various questions that are fairly easy enough, but the main thing to note, they're non-calculator, so please don't use a calculator when you're working out the answers. So the first topic is the rounding page. So it's this page here, so I'll just shorten this down and then we'll bring this page in. So first question, how many significant figures are there here? Just turn that around. The answer is 4. 4 there, 2 there. Right to the nearest hundred, 4,400. To 2 decimal places, 19.04. 3 decimal places, 19.040. And the last one, this one here, to 2 decimal places, 53.04. Just to recap, arrow at the second number after the decimal, box that off. The 8 will change that. That looks like 5,303, which gives you 5,304. That's how we deal with decimal places and significant figures. Okay, the next page is the two-way table page. I'll just shorten that down and I'll bring the question up now. Again, non-calculator, 600 pupils. It was completed by 275 girls, which means there must have been 325 boys. There's the working for that. Survey found that 83 boys were left-handed and 186 girls were right-handed. So we know the boys have to add up to 325. The girls have to add up to 275. 83 boys. So 325 minus 83 gives you 243, 242, which is the amount of right-handed boys. And then the girls is 275 minus the 196 gives you 79. Fairly straightforward stuff, boys and girls. Basically, all it's asking you to do is can you subtract numbers without a calculator. Next topic is reciprocals, and I'll do this now. I'll just shorten this down and we bring the reciprocals topic up here, the questions. First one, reciprocal of 1.5 is 1 over 1.5, which is 10 over 15, 2 over 3. Reciprocal of 9, fairly straightforward, 1 over 9. Reciprocal of 7, 1 over 7. Mel says every number has a reciprocal. Show that example is wrong. Yes, 0 does not have a reciprocal at all. And reciprocal of 1.8 is 1 over 1.8, 10 over 18, which is 5 over 9. Can I just take this opportunity just to talk about this question? If they do, for example, ask you for the reciprocal of 1.5, change that to 1.5 and then do 1 over 1.5, which is 10 over 15, which is 2 over 3. That divides by 5. Okay, and if they did this 2 1/4. Now 2 1/4 is a wee bit more difficult because you can't turn them into halves. So 2 1/4, if you remember, 2 1/4 is the same as 2 wholes of 4 and 1, so that's 9. That becomes 9 over 4, which flips around to become 4 over 9. These questions here very rarely appear. It's always the decimal ones. These decimal type of questions, they always seem to appear. But just in case they ask you like 1.5, 1.5 changed to 1.5. On the next page is to do with reverse sums. So I'm going to show you now on the next page how to do this. Shorten that down, bring it up. Now I prefer to do these as rounding sums. Okay? Because it makes it a wee bit easier just to try and work. Sometimes when you're doing left and right and one to the left and one to the right, it gets a wee bit more difficult. But this here is relatively straightforward. What you do is you look at what's happening. This is the original sum they've given us. They want to know with 32.5, I've rounded that to 30, 2.4 rounded to 2, so 30 times 2 is 60. Now, you have to pick the number which has not been used. That 32.5 revolves around that number, 2.4 revolves around that number, so our answer is going to revolve 780. Now, when we rounded 30 times 2, it was 60, so how can we manipulate this to make it look like 60? Well, if I stick the decimal in there, it's 78, so the answer is 78. Again, dividing one. 78 becomes 80. 24 becomes 20. 80 divided by 20 is 4. So my answer is going to look somewhere like the number 4. Something in around 4. Again, identify what's been used. That's at 78. That's at 24. So I'm going to be using this number 32.5 as the answer. Now, how can I make this number look like 4? If I stick the decimal in there, that gives you 3.25, which is there. This one here, the third one's a wee bit more awkward because that 12, you have to know that 12 is half of 24. So it's half of 24. So there's the 32.5. That 12 is half of that, which means our answer must be half of that. Has to be half of that. Now, if you're not too sure, just take yourself over to the side of the page and do 32.5 multiplied by 12. 32.5 multiplied by 12. 12 fives is 60, put down your 0 and carry your 6. 12 twos is 24 and 6 is 30, put down your 0 and carry your 3. 12 threes is 36 and 3 is 39. 3900, and because there's one decimal here, the decimal goes back in to give you 390. Okay, that's how you tackle that question. Okay, moving on up a bit. Again, here's a question from June 13. I'll just make it a wee bit bigger. Okay, I'm going to round again. So 16644, which is this number here, divided by this number here. So our answer is going to involve the number 76. How can I round this? Well, 16644 gives you 16 with 3 zeros. 21.9 gives you 20. Knock the 0 out there and the 0 out there, which leaves you with 1600 divided by 2. Excuse me. 1600 divided by 2 gives you 800. So I've used this number, I've used this number, so my answer must involve the number 76. How can I make 76 look like 800? Well, I stick a 0 on. 760 gives the answer for that. The bottom one, 75 times 219. Again, it's of no relevance. What they're saying is they're taking a batch of 219 off the answer. So basically what you could do 16644 take away or minus 219, but I think it's just easier to do the sum because then you can't make any mistakes. So long multiplication, multiply it out and you end up with the number 16425. So the next topic here is a topic for scale area, and scale area, remember, is called double-double. So double-double, if it was a scale factor of 9, it'd be 9 nines, which is 81. Okay, so let's look at a couple of questions in action. Move that up there. So question 8 says, a rectangle has a length of 12 centimeters and a width of 20. The rectangle is enlarged by a scale factor of 4. Write down a new length and new width. So it's just a scale factor of 4. It's nothing to do with a new area. So it's just a scale factor of 4. So 12 fours, the length's 48. And 20 fours is 80. Now I don't think you'll get anything as easy as that. That was June 13. I don't think it'll be anything as easy as that. It's probably going to be more like this type of question. Rectangle A has been enlarged by a scale factor of 4. How many times bigger is the area of the rectangle B? Okay, so if this is a scale factor of 4, the area is double-double. So it's 4 fours is 16. It is not 4. It's 4. It's not 4 twos. It's double-double. 4 times 4 is 16. Look for that question about area. It's always double-double. The next topic here is a topic on ratio and proportion. So we'll just square that off and we'll bring the other one up. Put that up there. So this question, fairly straightforward. Share 72 sweets in the ratio 8 to 1. We go through our processes and we realise that 8 is the box number. 8 eighths is 64, 8 ones is 8. In recent times they've went for reverse ratio questions, so watch for the reverse ratio. But in this occasion that's just a standard ratio question. This is the standard proportion question. This is for 20 pupils and they want to know how many for 50. So 20, I've written this out like this, makes it easier. So 20 is those items, another 20 will be those, and we only need 10 more, which is half of all those numbers, to give us the 40, the 60 and the 25. Just practice those answers to make sure you know what you're doing. Next question is a quick question on percentages. So we'll bring the question down. Remember, this is non-calculator. There's no point in cheating with the calculator now, just to practice without. 20%, as we know, is 2/10. So they want to know the VAT of that. So that means 2/10 of 3850. So 3850 divided by 10. When you're dividing by 10, the decimal moves 1 to the left. So that's 3.85 multiplied by the 2, which gives us £7.70p. Remember also that 25% is 1/4, which means you just divide by 4. And 75% is, of course, 3/4, which means you divide by the 4 and then you multiply by the 3. Those are the standard type of percentage questions that you'll get in non-calculator. Again, question 9. We've got a monthly bill of £40 and he pays 20% VAT. This time they want to know the total bill because you're going to have to add the VAT on. 20% again, 2/10. Show the examiner that. 2/10 of 40 is 4 times 2, which is 8. So the new bill isn't 8, the new bill is the 40 plus the 8, which gives you 48. Okay, fairly straightforward question on percentages. Okay, and the next one is a probability question. So we'll bring the probability question up. Again, this is the only time we use those words is whenever they're actually specifically given, and we need to write them down off that. Next week we'll have 7 days certain. You'll meet the President of the USA. Well, it's not impossible. It's unlikely. It would actually be very unlikely, but they haven't given us very unlikely, so it's unlikely. And the last one, write down an event which is an evens chance. The two main popular ones are tossing a coin and getting heads or tails, or the next baby born is a male or a female. Those are the two popular answers where you've got an event where the chance is evens. The next topic is prime numbers, so we'll just bring this number up here, bring this question up. Now this is a fairly popular question. I've seen a few of those now. Peter says when you add any two prime numbers together, you always get an even number. Show an example that Peter is not correct. Now, we need to know the prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. Those are the first 8. Now, when you add any two prime numbers, you get an even number. So, let's take 2. 2 plus 3 is 5. Well, that's odd. Then let's try another one. 3 plus 5 is 8. That's even. So, Peter's saying you always get an even answer. Well, that's not true, because we've just proven here that we've got an odd answer. Generally, all the other prime numbers are odd apart from 2. So if you add 2 to any number, it'll give you an odd number. So for example, 2 plus 7 would be 9. That would be odd as well. So basically all you have to do for those sort of questions is write down the prime numbers and go through a couple of examples to prove what the question is asking. Next topic is negative numbers. Let me just bring this question up. Work out the value of minus 42 divided by minus 6. Key thing to do, disregard the negatives, so just do 42 divided by 6, which is 7. A minus and a minus give you a plus, so that's plus 7. So for example, if I had them in this answer question here, 35 divided by minus 7, disregard the minuses, do 35 divided by 7, which would be 5. This here is a plus, this is a minus, so a plus and a minus give us a minus answer. Next topic is inequalities. This is the question on inequalities. Now, I'm going to spend a few minutes on this. Let's look at the first one. So what we do is we write down the inequality first of all, and we write down if it's included or not included. That's the inequality. You draw your number line generally always from 6 to minus 6 with 0 in the middle. Now, not included means you don't include any numbers that are coming up here, and you include the numbers that are coming here. We divide it by 3 because 3 is the middle number. So you've got minus, so when you divide minus 7 by 3, you get minus 2 with a wee bit left over, and then you've got 2, a whole. Generally speaking, you'll have 1 with a wee bit left over and a whole number. Now, a good way to remember it is this here. If it's less than, if it's not included, you stroke out the remainder. Okay, so you can just stroke it out. That's what means it's not included. But the 2 is included. So therefore, the minus 2 will be included here, and right up into the 2 here. We're including the 2 because it says included. So it's minus 2, minus 1, 0, 1, 2, which is this on the number line. Okay. Not included here will generally be with the wee bit that's left over. That means you don't include the wee bit, but you include the whole number. Let's see if we can follow that rationale through again. Over here, we've got the value of minus 2 to 3n to 12. Again, not included here, included here. So 3 divided by minus 2 is not with something left over, not in a wee bit, not remainder something. Write that in. So we're going to stroke that remainder something out, and we're going to include the naught, and obviously we can include the minus 4 because it's included. So we've got naught, 1, 2, 3, 4 for that on the number line. And then finally this one here. This is a wee bit easier because there's actually no remainders. Both these numbers divided by 3, that gives you minus 9 divided by 3 gives you minus 3. 3 divided by 3 gives you 1. Now, included means that the minus 3 is included. The 1 is not included because it's only got the 1 sign here. So really what that means is you're drawing it from minus 3 not up to 1. We're not including 1 because 1's not included. So the numbers are minus 3, minus 2, minus 1 and 0. Okay, these signs, include means you include the number minus 3, not included means you don't include the number 1. Just to recap, if it's like a remainder of something, if it's like not remainder of something, if a number doesn't divide in wholly, you can stroke the wee bit out, but take the number that goes with it. And the next topic is indices. So I've just done a couple of extra indices questions. This one here is obviously p to the power of 8 because brackets means multiply. This one here, now if there's no power, that's actually 1, so that's p to the 1 times p to the 2, which gives you p to the 3. And then finally underneath them we've got these couple of examples. Q to the 4 divided by Q, again that really means Q to the 1, and dividing means subtract, so that means 4 minus 1, which gives you Q3. And finally here we've got x, which is x to the 1 times x to the 2, which gives you x to the 3, divided by x to the 4. 3 minus 4 gives you x to the minus 1. Okay, just learn those standard rules for indices. So our next page is conversion. It's a wee bit back to front because actually after that there's actually a question about rotations. So again, what is the order of rotational symmetry of that? Well, it has 5 because there's 5 points on it, but don't guess, trace it and then move it round and you'll see it'll fit there, there, 5. So that's 5. And then all the lines of symmetry means you go from that point to there, from there to the point. If you draw them in, you can see there's 5 lines of symmetry. And the one underneath, mark X at the centre, well clearly X has to go there, right in the middle. Okay, so those are fairly standard questions on rotational symmetry and lines of symmetry. However, let's get the conversion question, which was the one we were looking for, which is this one here. Okay. The petrol consumption of a car is 64 miles to the gallon. Now we need to know our rules for imperial and metric. Okay, gallons to litres means if you're going from gallons to litres, you multiply by 4.5. Litres to gallons is divided by 4.5. So 64 miles gets you 1 gallon, which is the equivalent of 64 miles, which is 4.5 litres. Now, we want to know, we want to divide 64 miles by the 4.5 litres. Now, because it's non-calculator, remember, we can't actually do that. So remember I told you a trick, if it was by a half, to get rid of the half, you multiply both numbers by 2. So 4.5 times 2 gives you 9, and 64 times 2 gives you 128. Do it as a sum and you realise you get 14.2. Now, it's asking how many miles should the same car do to the litre? Well, 14.2 rounds to 14. Okay, but this is the key thing here. Even if you're not too sure, if you get this done and multiply this out, you'll get at least some of the marks for those types of questions. Again, fairly straightforward. Miles to kilometres, kilometres to miles. So we're going from 10 miles to kilometres, 10 divided by 5 times 8 gives you 16. 40 kilometres to miles, we're going kilometres to miles, divide by 8, multiply by 5, which gives you 25. Learn those 4 key facts, boys and girls, on changing from imperial to metric. From miles to kilometres, from gallons to litres, from pounds to kilograms, and from pints to litres. Learn those 4 things. Now, this is a good question on constructions for bisectors. Now, even though I don't have a compass here, if you pause the video as I'm explaining it and have a compass in front of you, this will help you explain, this will help you do it. So pause the video now, go and get yourself a compass, a ruler and a pencil, and I'll talk you through exactly what this question is. Okay, so let's move that up and get this question down. Okay. Question 18 says, use a ruler and a compass only, construct the bisector of the angle. Bisector just means you're cutting it in half. There'll be 2 parts. Okay, so basically what it is we have a line, we have an original line, original angle here to here. Okay, everything else that I have done here is what you need to do. But it's fairly straightforward. It actually only takes you about 15 or 20 seconds to do it. Here's how you do it. You take your compass, first of all, you put it at that point there. You open it up, well, about a quarter or a third of the way up the line. It doesn't have to be an exact science, generally about a third. Keep that distance apart. And what I want you to do is put your compass there and draw your arc there. And actually you can draw it all around as well. Draw it there and there. But if you want to continue it as one long circle cut, that's fine. Okay, that's the first thing you do. So it cuts the angles in half. Then what you do is now this is the crucial thing. You make sure the compass doesn't change width. Once you've done it there and got these 2 arcs, you take your compass and put it at that point and draw your arc again there. Put your compass at that point and draw your arc again there, and you'll end up with 2 other arcs that intersect in around here somewhere. you put a dot in the middle and you draw a line from there right through it. That's exactly all you do. Okay, so just to recap, put the point of the compass on this point here. Open up the compass and draw an arc on both sides. So open it up about a third of the way and draw an arc here and here. Do not change the width of the compass now once it's set. Then keep the compass the same distance at all times. Then put your point here and your arc will be drawn there. Put your point there and draw your arc round, and you'll find the 2 points will meet. Now, not necessarily where mine is, it might meet on up here, and then draw your line straight across. Now, practice that a few times, boys and girls. That is called constructing a bisector. Very, very easy to do, and a couple of easy marks if you just follow along. Point here, arc and arc. Points then go to here and here. 2 more arcs, cut it in the middle. Okay, our next topic is algebra. So I'll just bring this one down. Again, don't be put off by this. Don't be put off. We've got to get a couple of these marks. There's, I think, 3 marks here. We've got to make sure we get a couple of marks here. Don't be put off by all the jazz. N represents a number. N on the next whole number on the number line and the next one after that are added together. So basically what happens is you pick a number, the number next to it's going to be added, and the number next is going to be added. What type of whole number is the answer? Right, well this is what they want. They want you to use algebra. So that's n. Then the next number is n plus 1, and then the one after that is n plus 2. So if you add all the n's, that gives you 3n plus 3. And if you divide that by 3, it gives you 3 brackets n plus 1. If you can't do that, if you follow that format, that's fine. However, if you're not comfortable, use the numbers. So let's say we used n to be the number 3, which I've done. So n is 3. The number after 3 is 4. The number after 4 is 5. So that's 3 plus 4 plus 5, which gives you 12. And 12 is a multiple of 3. Okay? If I use 5, it would be 5 plus 6 plus 7, which is 18, a multiple of 3. Any numbers that we pick when we add them, any numbers that you pick that are consecutive beside each other and you add them up will always divide by 3. So n is just the first number, n plus 1 is the number next to that, and n plus 2 is 2 numbers away from that. So don't be put off, boys and girls, by that type of question. Just take a deep breath, read through what it's asking you to do, underline the important things, n, the whole number in the n, and the next one after that, and then process that, and either use algebra to try and work it out, but always use numbers as well, and show the examiner. Don't just appear with the number 12, show the examiner what you're doing. So the next question is about formulas and expressions and creating formulas. Okay, so we'll have a look at that question. Okay, good starting here. Which is an equation, which is an expression, which is a formula, which is an inequality. An equation is just like 2x plus 4 equals 6. You've got to have only one set of x's. You've got to have an equal sign, excuse me, and a number the other side. That's an equation, which takes us down to here. An expression looks like an equation, but doesn't have equals. 3x plus 2y, 3x plus 4, 3x plus 16q. Doesn't matter as long as it doesn't have equals. This is equals, this doesn't. A formula has equals, but it's also got more than one letter. T equals 2p plus q. Perimeter equals 2l plus 2w. Area equals pi r squared. Formula has an equals, but has a couple of numbers, or a couple of letters. Equation has an equals, but it's only got one letter. And an inequality is something with a greater than or less than sign. Okay, learn them, boys and girls. Now, this is the one I'm after. Again, we've got to cut through this here to see if we can make sense. X pounds is shared equally among C children. Write down a formula for the amount of money A that each child should receive. So, with them sort of questions, put some money to it so you can make sense. Say it's 30 quid. £30 is equally shared among 3 children. How much would each child get? Each child would get 10. So A is how much each child gets. So that's 10 equals X is the amount of money that they had, which is 30, divided by C, which is the number of children, which is 3. So the formula is A equals X divided by C. You get the tenner because you've 30 divided by 3. Put the numbers in to help you, but that's the formula. Just follow it as you see it. Don't be put off by it and see if you can work it out. Okay? And then our next topic is obviously distance, speed, time, average speed. So we've done loads of examples in this, but we'll run through this question here. If I can get it down now. Okay, put that up. Okay. Well, this is a relatively easy one because it's a non-calculator. Again, with all these type of graphs, we must, I keep reiterating, we must work out what each one of them lines going up is and tell the examiner they're going up in 2s, these are going up in 3s. Okay, give a practical explanation for the horizontal line. So the horizontal line, they're on a coach, so they're obviously going to the shop or they're going to the toilet or they're taking a break. Do not just say they've stopped. That is not enough. You need to give a practical example, an example of why they've stopped. Okay, the average speed for the complete journey from Bridgetown to Mayfield. Excuse me. So the distance, we know the distance. If we look at the distance takes us right to the top, which is this number here. You go across and you work out, because we know they're going up in 2s, use a ruler and that gets you to 86. So we know the distance is 86. We don't know the average speed. We're trying to find that. So cross that out and that means distance divided by time. We know it's taken 2 hours, so 86 divided by 2 is 43. We do not have to multiply that by 60 because this is a whole hours. If it had been 15 minutes, you would have had to multiply it by 60. But because this is a nice handy number, because it's non-calculator, it gives us an answer of 43 kilometers per hour. Now this question here is a wee bit more trickier. It's giving you 2 pieces of information. It's saying Helen's running up the hill, takes an hour, and she's turning at the top and she's running back down. And she's running 6 kilometers per hour. How long does it take her in total? So you need to work out about going up the hill. So how long is all about time? So we're looking to find time. So the distance up the hill was 4. The time it took was 1 hour because it says 1 hour. So 4 divided by 4 gives you the 1 hour. The distance is 4. The speed is 4 as well. So 4 divided by 4 gives us that 1 hour. So it's taking her 1 hour to run up the hill. Okay, that's her running up the hill in 1 hour. Now, she's at the hill and she's coming back down and she's running 6 kilometers per hour. So we again need to know the time. So over here now, we have distance, speed, time again. Going down, we know it's again 4 kilometers. This time, it's her speed is 6. So it's 4 divided by 6, which is 2/3. Now, because it's 2/3, it's 2/3 of 60. Okay, so it's 60 divided by 3, which is 20. 20 times 2 is 40. So it's 40 minutes coming back down. 1 hour to go up and 40 minutes to come back down. So if it's 40 minutes there and an hour there, it gives 1 hour 40 in total. This is another good question because I got a decimal number. Okay, we would not turn this into, if it was a calculator exam, we could do 240 divided by 150 multiplied by 60. Non-calculator, very hard to do that. So write the sum as you see it. It's 240 divided by 2.5. 150 is 2.5. Remember I said if it's a decimal, multiply it by 2 to get rid of it. So 2.5 times 2 gives you 5. 240 times 2 gives you 480. Do it as a sum. 480 divided by 5 gives you 96 kilometers per hour. Okay, that's how you do those sort of questions. Always show the examiner the box. It makes it easier. Average speed, because we're looking for average speed, cross it out and you know that's distance divided by time. Okay, and the next one is dividing by decimals. Just bring it out. Very straightforward question. 600 divided by 0.2. The key thing to remember is to write it as a dividing sum. Where to get rid of that decimal, you put the 0 up here, divided by 2, and 6,000 divided by 2 gives you 3,000. Okay. So the next few pages are all about just drawing lines on different types of scales. Okay, so let's start them off. I think we'll do maybe 2 at a time. Okay, so the first one is draw an arrow showing 225. So we need to know these are going up in 50s, so 225 is there. Next one, what time is on our clock? Be very careful, folks, when we're working about time. It's because it's morning, we've got to write in 5:48 AM. Do not write down 5:48. That would only get you 1 mark. AM, because they're telling you it's the morning time. Again, you have to work out what these barriers are. They're going up in 0.2s, 2.2, 2.4, 2.6, 2.8. So that number is 2.3. Again, we have to work out again what these are going up in. That's 100, 200, so they're going up in 20s. Work your way along, you'll find out that's 180. Next one, this is 12.5. These again are going up. Find out what they're going up. They're going up in twos, so that gets you 66, 68. So that's 67. This one here, on the last diagram above, marked clearly where an arrow a speed of 72 kilometers an hour. So 72 kilometers an hour is there. Again, these are going up in tens. We're looking 55, so 55 is exactly there. And these are going up in 200s. So we work that out, you'll mark 600 there. Again, all these graphs, please write down, work out what they're going up in. Once you know what they're going up in, it'll make life much more easier to work out the answers. Next page is a wee bit of work on conversions and conversion graphs. So we'll bring this page down here. It's a bit tricky here. Bit of a tricky fly type of question. They want to know the real engine speed. So we know that they're going up in 0.25, so that's 4.25. But again, it's a 2-mark question. That's more or less telling you that it's more than just reading 4.25. Because it's multiplied by 1,000 revs per minute, you actually have to multiply 4.25 by 1,000. Now multiply by 1,000 moves the decimal, moves 3, 1, 2, and then put another 0 there to 3. Gives you 4,250, because that's the real engine speed. Part B, if you work your way through there, you'll see 10 ounces give you 12 buns. So 20 ounces gives you 24, and 20 ounces is the same as 500 grams. So the reading on the scale is 480. So if you work out at 480 away from 500, that gives you 20. Okay, that's how you work out 20 ounces is 500 grams, because 20 times 25 gives you 500. Okay, tricky type of question, 4 marks for that. Again, work out with these. These are going up in 40s, because that's 400. So there's 40, 80, 120, 160. That's 200. Okay, so that's why that measures 480. We had to work out 20 ounces to be 500 grams, because 1 ounce is 250. So then after that, it's just basic 500 take away 480. A lot of marks there, folks. Please make sure you pick up a couple of marks. Again, very important. Reading the scales, working out the barriers. On this conversion graph, we have we've actually got the points to plot. These are the ones that go across the bottom. These are the ones that go up the top. Again, key point to note. Work out exactly what they're going up in. These are going up in 2s. These are going up in 20s. So plot the points first of all. Plot them nice and clearly, not X's, wee circles, and draw the line right through it. And then it says for 3 marks. Susan has a gold bar with a volume of 20 cubic centimeters. What is the value of the gold bar if 1 gram is worth 20 pounds? So on the graph, 20 centimeters cubed, if you go along to 20 centimeters cubed, up to hit your line, come across, you'll read that as 350. So I have to then multiply 350 grams by 20 pound. So over there, I'll just try and make that a bit bigger if we can. Yeah. So did it as a sum, 350 times 20. 20 times 0 is 0. 20 times 5 is 100, put down your 0 and carry your 1. 23 is 60 and 1 is 70. So that gives you £7,000. Okay, key thing to note, make sure on our graph that we put our lines, anything that we're doing, we show the examiner we're going up to hit the conversion graph. Next page, first thing of course, as usual, work out the barriers. They're going up in 4s and these are going up in 4s. The average weight of an American footballer is 248 pounds. Now, they have drawn this conversion graph. Very rarely they draw it in, but they've drawn this in. So we go along to 248, up there, hit it, and coming across, and we work that out to be 112 kilograms. Part B. Justin weighs 72 grams. His cousin weighs 165 pounds. Basically, you have to look at one compared to the other. So go along to 72 kilograms on the graph. I've marked it in there, 72. Across to hit the line down. I've worked out 72 on the graph to be 160 pounds. He's 160. Leroy's 165. Justin says, does he weigh more? No, he doesn't. He's not correct. He only weighs 160. He's £5 less. A different type of question here. They've only given you one piece of information. 2 gallons, approximately 9 litres. Well, what I've done, I've multiplied them up. If 2 is 9, then 4 is 18, and then double that, 8 is 36. I found those 3 points will obviously not. Join the line very carefully and use the graph 24 litres, which is here, across and down to give you 5.4, and 14 gallons. Now, here's the thing, there's no 14 gallons. It only goes as far as 10. So I've worked out 7 up and across. 7 is 31. So 7 is 31, 14 is 62. And we should know this anyhow. To go from gallons to litres, you multiply by 4.5. Litres to gallons, you divide by 4.5. Again, you'll note I've put in the barriers up in 1s, up in 0.2s. The last page is, again, the last page in this booklet is a conversion graph. Again, these are going up in 0.2s, these are going up in 1s. They've put the graph in. Use the graph to work out the number of litres, which are equivalent to 8 gallons. So 8 gallons over and across, and that gives me 36. And the second one, the number of gallons equivalent to 25, up and across, and that gives me 5.5.